All right, gang. Math 5130, transitioning into multiple regression from simple linear regression. And the beauty of this transition is if you have a pretty firm understanding of simple linear regression, then running a multiple regression and reporting the results is not much of a stretch. So what we're going to do here, I have a data set. It's called self-care. This is actually from lesson 4. We used it back, I think, with the NOVA. But what I want to do here is switch gears and demonstrate a multiple regression. So we are going to predict SSQ score from age and HF underscore SCI. So I'll just call this HF from now on. In the first demonstration that I want to give you, I just want quantitative predictors only. We could include hospital as a predictor. We could switch gears and have self-care as a dependent variable once we get into logistic regression. But let's crawl before we actually start running. So we're going to predict again SSQ from age and HF. And the beauty of that is that's exactly the way it goes in the model. We're going to predict that from these two variables right here. So you can see how I run my model. And no, excuse me. We will access that in just a second. So I'm going to go ahead and run some means and report those. I kind of like, I don't think I've demonstrated this before. I kind of like running it this way. So I get the mean and standard deviation for SSQ, which I've reported. Now I can just hit my up arrow and then go right here and just change those. So 61.56 and standard deviation reported. And then this one's a little bit of a pain to type. It's easy to make a typo. If you do, it's going to give you an error. And we get the mean and standard deviation for that predictor. So my research question is stated, our age and HF statistically significant predictors of SSQ. I think this is wrong. Yeah, there's a typo right there. That should be 43. So no cases had missing data, so the results were calculated on the full sample of n equal 43. Since the number of cases per predictor easily exceeds 15, see field 2012, there's no concern with adequate sample size. Let me explain what that means. Now, a lot of researchers have shown that you need at least 15 cases per predictor. So with us having 2 predictors in our model, 2 times 15 is 30. 30 is not bigger than 43. So I'm not worried about adequate sample size. Now, if I added a third predictor, if we did have a third predictor here, 3 times 15 is 45. That's pushing it just a little bit. I would probably, because 43 and 45 are so close, I'd probably feel comfortable going ahead and running the model. But yeah, it's not a concern. We have 2. Next thing I'll do is I'll dive into the assumptions. Sorry, it's early. I'm going to run Shapiro test on our residuals for the model, again, that we created, or I created right back there. And you can see that we violate the normality assumptions. So I reported these results right there. However, the QQ plot, which if you recall, we have to get that from installing the, I forget what this is called, yeah, the GGPUBR. Now, if you didn't follow along with the videos like you should have, you have to install that package before you can access the library, but I installed it in the previous video, so I don't have to worry about it. And then I just use the GGQQ plot for the model residuals. And you can see that we get a little bit of a contradiction because when I run the theoretical band, there are only two observations outside of the band. So I tell the reader that. First of all, I copy and paste that right here. And then I tell the reader that Shapiro test was significant at the .01 level, but the QQ plot really showed no reason for concern. The next thing we get into is we have to test independence, and we use that the Durbin-Watson test. You're probably at this level, you're not really going to understand it, but oh shoot, okay, we have to access the library for car first, and then I think we can run this. Yeah, we can. Now, this is going to drive you crazy, at least it does me. Sometimes with the autocorrelation test, again, a test for independence, you can run this thing. Let me show it to you, probably. Yeah, you can run it multiple times and you get different values. There's a reason for that. I forget exactly what it is for the p-value. Run it again, probably going to get something a little bit different. You can't control that, but the test statistic, which is the most important part, stays consistent. So our p-value is greater than 0.05. Report the Durbin-Watson statistic at 2.8. So there's no concern with independence autocorrelation with this model. Equal variance assumption, I would do an eyeball test on the model. So I would just plot the fitted values for the model and then the residuals for the model on the fitted values. And we have pretty much equal variance as we go across. Shotgun blast, no discernible patterns. Copy, paste that into your document, and you're flying high. Now, something else new for multiple regression, in addition to the Durbin-Watson test that you need to report. And again, you know, as a user of statistics and not a statistician, not a background in mathematics and statistics, you're not going to thoroughly understand all the mathematics behind calculating the Durbin-Watson statistic and these VIF factors that I'm getting ready to calculate for you. But you act like you do. Okay, you go ahead and report them so the reader knows that you've tested for these assumptions.